Hello, students. Okay, so we are going to learn about comparison tests, which is 11.4. When I do this lesson, you might want to pause every once in a while just to be able to copy some of these things down. So the first thing is there are two comparison tests. One is the comparison test, which is this one here, and there's another one called the limit comparison test. So the comparison test here, it says suppose that you have a series AN and the series BN, and both are series with positive integers, positive terms. If you have the series BN and you know it's convergent, and all the values of AN are all less than BN, so if you know that AN is smaller than BN, and you know BN converges to a value, then you know that the series AN is also going to be convergent because since AN is less than BN, if this converges, then these have to converge since this one also already goes down to a value. If you have a series BN and you know that it is divergent and you know that AN, all the values of it are greater than BN, then you know that the sum of the sequence AN is also divergent. Because if this one diverges, then if this one is greater than that, then since this one diverges, this one also has to diverge. Okay, so take a moment to copy all of this down. You might need a pause. And this will definitely go on a flashcard. Now, this series is the comparison series. You need to know information about Bn in order to conclude something about the series of An. Okay, so Bn is the one that you need to know about. So here is an example. Here's a question. Does this series of this sequence converge or diverge? So if we look at it, we go, okay, well, I have this expression. I have 5 in the numerator. I have 2n squared plus 4n plus 3 in the denominator. Now, if you notice, there is this n squared there. Here's n to the first power, but the highest degree is n squared. Now, if you remember about our p series, we know that if our exponent is greater than 1, we know that it's going to converge. So we are going to think of something similar to this sequence that we know would converge. So what we're going to do is we're going to say, okay, well, my problem is asking about this expression here. So I'm going to say let AN equal this. And I know that something similar to AN, which I'm going to call BN, would be 5 divided by 2n squared. Now, why did we pick this? Well, this will match up with this numerator, and this leading coefficient will match up with this. And this degree, n to the second power, matches up with this. Now, what happens to this expression here, or this part of the expression? Well, we know that if I add anything on to my 2n squared, what's going to happen to my denominator? It is going to get bigger. So if it's going to get bigger, that means then the overall fraction value is going to get smaller. So therefore, I know that AN is going to be less than all of my BNs. So just as long as I've got this expression is going to always be greater than this because my AN has this added onto it in the denominator. So I know that my AN is always going to be less than or equal to my BN. Now, what do I know about BN? Well, I know that the sum of my BN is going to converge because if I pull this out, just like we can do with sums and with limits, we can pull out this coefficient. Sorry. I can pull out this coefficient, and I know that this expression right here converges. Why? Because it is a P series. And I know that my P is greater than 1. So, since it's greater than 1, I know it's going to converge. And since that converges, and since Bn is greater than all Ans, An must be smaller, then I know that this series, which is smaller than this series, has to converge by the comparison test. So when you do this, what you have to do is think about, okay, how can I get an expression that is similar to the one that I have already, but I know something about that expression? You have to already know if that expression, if the series of it converges or if it diverges. So that's what you have to do first. So once you have an expression that you can think of, then you must also know if it converges or diverges. Okay, that's the first example.